Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about a recent earthquake that has occurred in the Delhi region, and few hours after another earthquake has occurred in the Siwan region of Bihar. So in this video, we will try to understand what is the magnitude of the earthquake that were recorded here, how magnitude is recorded, why these areas generally record earthquakes after every few years. So let us try to understand this in more detail. Now, as per the current news, earthquake or strong tremors is how we define earthquake, that is a very violent shaking of ground. If you try to define earthquake, simply you can define it as a violent tremors that develops in the or near the surface of the earth or on the surface of the earth due to the disturbance, a kind of temporary disturbance that occurs in the rocks of the crust of the earth. As we know that earth is divided into three layers: the crust, that is the uppermost layer, then you have the mantle, and the innermost layer, the core. So the disturbance that generally is restricted in the crust part of the earth results into the earthquake. So as per this recent report, at 5:36 am today, the earthquake of magnitude 4.0 has struck the national capital. So we'll try to later on decipher what does the 4.0 magnitude largely refers to. Now, as per the National Center for Seismology, which is the nodal body for monitoring of the earthquake in India, working under the control of Ministry of Earth Sciences, have issued a notice that earthquake of magnitude 4.0 on 17th February 2025, 5:36:55 Indian Standard Time. The latitude and the longitude of the earthquake is also mentioned. And now, apart from this, also you'll see that the earthquake's depth is mentioned. The earthquake's depth basically refer to the focus, the depth of the focus. The focus is the point from where the earthquake waves originate, where exactly the disturbance originates. So the disturbance originated somewhere 5 km deep below the surface of Delhi. Now, the area, if we talk about where this epicenter of the earthquake lies, that is the area which is mostly, we can say, disturbed by the earthquake, lies in the Delhi, around a lake region. And this area which is close to lake has experienced minor low magnitude quakes. This is not for the first time that this area has experienced earthquake. Low magnitude earthquakes approximately every 2 to 3 years is something that has been a norm in this particular area. For example, in 2015, a minor earthquake of 3.3 magnitude has been witnessed by the same area as well. Now, just after a few hours, 5:36 is when the earthquake struck Delhi, and around 8:02 am, the earthquake struck a region of Bihar, that is in the northern Bihar. You have a district called as Siwan. So it is very, very close to the Patna, the capital city of Bihar, as you can see. This earthquake was also of same magnitude, that is 4.0. However, the depth of the earthquake, if you look here, it is farther deep than the first one. In the case of Delhi, depth was 5 km, and the case of Patna or Siwan, we can say the depth was 10 km. Now you'll ask that why we are so much worrying and concerned about the depth. So depth has a very important role to play in understanding the implications and the after effects of the earthquake. Generally, as a rule of thumb, the deeper is the source of earthquake, lesser will be its impact, or less disastrous and damaging the earthquake will be. While if the earthquake's depth or the focus depth is close to the surface, earthquake will be much more destructive in nature. The reason is very simple, because if the depth of earthquake is very, very far, the origin point of the earthquake wave is very, very far. By the time these waves reach the surface, they will lose and dissipate most of their energy. So the actual energy received on the surface will be relatively low. Now, if you imagine if the depth is very less, suppose that 2 km, 3 km, something like this, so huge amount of energy will actually observed on the surface that will cause a massive destruction and damage to the infrastructure. Now, obviously, Prime Minister Modi also has taken a note of this instance, and he has also stated that tremors were felt in Delhi and the nearby areas. He is urging everyone to stay calm and follow safety precautions, staying alert for the possible aftershocks. A very important term that is used generally in the earthquake is the aftershock. Authorities are keeping close watch on the situation. Now let us try to understand what do we mean by the term foreshock and aftershock. So when the earthquake waves strike the surface, that is what we call as the main shock event. Now many times before the actual earthquake waves strike the surface, they are preceded by what you can call as the foreshock, which is again a low magnitude of earthquake in the same location. And then after the main shock event has occurred, for example, in the case of Delhi, we know that a 4.0 magnitude has struck Delhi. Now, after that main quake or main shock, there can be several aftershock. These again are smaller, very smaller magnitude of earthquake that occur in the same general area. An aftershock, it does not necessarily mean that it will occur on the same in the same day. It can occur during the days to years following a large event or large main shock. So they basically represent a minor readjustment along the portions of a fault that slipped at the time of main shock. Now, what we are talking about is the fault and the readjustment along the portion. Let us try to understand this also in more detail. Now, first we have to understand that why generally earthquake occurs around the on the earth's surface. So earthquake are simply nothing but it is caused by a sudden slip on a fault. Now, what is a fault? Fault is nothing but the break in the rocks of the crust that largely is a result of the plate tectonics. We know that the entire upper surface of the earth is divided into several different plates, and these plates keep on moving relative to each other. So many times when these plates collide with each other, the rocks try to push against each other, and due to the pushing of the rocks start to get compressed and the energy stores in the rock. Now suddenly, due to further compression, the rocks can slip along the edges, and this slipping of the rocks along the edges results into the release of the energy in the form of seismic wave, which we observe in the form of earthquake. So the tectonic plates are always slowly moving, but they get stuck at their edges, as we discussed, due to the friction. So when the stress on the edge overcomes the friction, there is an earthquake that releases energy in the waves that travel through the earth's crust and causes the shaking, the tremors that we feel. So when you talk about the aftershock, these refer to such event where again readjustment of the fault, readjustment of the rocks of crust occur, releasing a small amount of energy as compared to the main shock event. This we also can understand from a particular diagram here or the image here. As we can see, suppose this side you have one plate and this side you have the second plate. So these plates are moving relative to each other, and that is why the rocks of these plates are getting displaced relative to each other. So as shown from this particular image, you can see here the rocks are moving relatively in the northward and upward and downward direction. So the actual break or disturbance in the rock where actually it originates is what we term as focus. And then just directly above the focus is the point on the earth's surface that we refer as epicenter. Now epicenter, why epicenter is important? Because epicenter is the place where the earthquake waves will reach first. The reason is because it is the shortest distance from the focus to the surface, and that is why, since the earthquake waves are reaching here first, the energy they will contain will be highest, maximum, and that is why the maximum damage during the earthquake is recorded near the epicenter. So 2 points we have to keep in mind. One, the focus, also sometimes referred as hypocenter, the place of genesis of the earthquake waves, and the epicenter, that is a point directly above the focus on the surface where we record seismic waves for the first time or earliest. Now the question comes that why we are witnessing so many earthquakes in the northern part of India. The reason is because of the movement of Indian plate toward the Eurasian plate. For example, we know that many million years back, the Indian plate was part of a landmass called as Gondwana land that was in the southern hemisphere. Now after spreading from Gondwana land, India began its northward journey, and then somewhere about 10 million years ago, the Indian plate collided with a much more larger Eurasian plate, which is another continental plate in the north. Now, due to this convergence, due to this collision, the sediments on the rocks that were present near the edges of the plates, they upfolded, they were pushed in the upward direction. And this upfolding of the sediments on rock have resulted into the development of the Himalayan mountain system. Now, after collision of Indian plate and Eurasian plate, the collision or the plate movement did not came to an end. Even today, it is believed that Indian plate is continuously pushing against the Eurasian plate at the rate of 4.5 centimeter per year. That means still stress keeps on building along the edges in the rocks of these plates, and whenever this stress is released due to the break in the rock, the earthquake is something that we witness around the entire Himalayan belt region, spanning all the way from Afghanistan, Pakistan, China. Then you have the Tibetan Plateau. Entire northeastern India we can talk about, including the northern part of India where we have the Himalayan mountain system. So the earthquake in Delhi is obviously a result of plate tectonic between or tectonic plate movement that we are seeing between the Indian plate and the Eurasian plate. Now, Delhi is prone to earthquakes and falls in zone 4 of seismic active areas of the country, which is the second highest category. Means Delhi is lying in the second most prone region of India for the earthquake. In recent years, region has experienced several magnitude 4 earthquakes However, as per the report published by United States Geological Survey, Delhi has not recorded any earthquake of magnitude 5.0 or higher in the last 10 years. And since Delhi lies along the edges or near the edges of the Himalayan fault zone, where the Indian plate and Eurasian plate are colliding together, Delhi also frequently feels the tremors or shaking from the distant earthquake that might originate in Himalayas, Afghanistan, or China, as we have discussed before. Now, when you talk about the zone or the seismic zones of India, it is classified by the National Disaster Management Authority, and India, as we can see, is divided into four major zones, that is Zone 2, Zone 3, Zone 4, and Zone 5. Zone 1 also used to exist earlier, but after 2001 reclassification, Zone 1 and Zone 2 are merged together. Now, if you look at the Zone 5, it is this red areas that you are seeing along the Himalayan belt in Jammu and Kashmir, Uttarakhand, Himachal Pradesh, a part of northern Bihar, and the entire northeast India. These are most prone to earthquake. Reason again is simple, because these are the regions where you have the active faults due to the break in the rock due to the pushing of Indian plate against the Eurasian plate. And around these areas, this is where you have the Delhi, so it lies in Zone 4. Then you can see the yellow line or the yellow region represents Zone 3, and the blue zone represents Zone 2, which is least prone to earthquake, where damage or risk of earthquake is very, very minimal in the nature. So that is how the classification of India seismic mapping or seismic zone has been done. Now, when we talk about Delhi and we talk about that it lies in Zone 4, what it means? It means that it lies on an intensity scale of 8. That means any earthquake will have a significant damaging effect on the Delhi. For example, many people will find it difficult to stand even outdoors. Furnitures may be overturned, waves may be seen on very soft ground, older structures partially collapse or sustain considerable damage, and large cracks and fissures open up the rock fall. So that is what largely is the risk associated with Zone 4. Now, obviously, the risk will increase as the magnitude of the earthquake increases, and these risks will decrease as the magnitude of the earthquake is lower. So in this case, in the present case, the magnitude of earthquake was very, very low. It was 4.0. So such kind of effect was not observed. Even as per the recent report, there has not been any losses of life, fortunately, due to the result of this earthquake. Now, the scale that we are talking about, on which we are measuring the magnitude, on which we have discussed that the current earthquake was of magnitude 4.0, is what we refer as the Richter scale. Richter scale was given by Charles Richter in the year 1935. And as we can see, it is a kind of logarithmic scale. So as the value on the Richter scale of earthquake rises, we see a huge amount of change in the energy released by the earthquake. Actually, every unit increase on the Richter scale represent that the energy released will be increased by 31 times, and that is why you can see the energy released by a 4 earthquake is equivalent to 60,000 kilograms of the TNT. On the other hand, energy released by a magnitude 5 earthquake is almost 100,000 kilogram of the TNT. So as a change in the Richter scale, a unit value occurs, you see a significant amount of energy changes or the release of energy that is changed here. So if we talk about the 4.0 earthquake, it lies somewhere between the minor earthquake and the light earthquake. 5 is moderate, 6 is strong, 7 is major, 8, 9, 10 are considered as a great earthquake. So the Richter scale measures the magnitude of earthquake on a scale between 1.0 to 10. Now, when you talk about the Richter scale, one thing we have to understand is the earthquake of magnitude more than 8, more than 9 is something very, very rare. And thus, if we try to understand the top 5 super mega earthquakes that we have witnessed in the world, the biggest earthquake that we have witnessed on the Richter scale was 9.5 in the year 1960 in the Valdivia region of Chile. Similarly, magnitude 9.2 earthquake is associated with Alaska in the United States in the year 1964. And most recently, you would remember that in the 2004, exactly on the 26th of December in the Indian Ocean, many countries have witnessed tsunami phenomena. And that tsunami was a result of a 9.2 magnitude earthquake that occurred along the Sumatra region of Indonesia. Further, in the Tohoku region of Japan in 2011, that has caused Fukushima nuclear disaster as well. The earthquake was having magnitude of 9.1, and then 9.0, that is in the Kamchatka, Russia in the year 1952. So these are the mega earthquakes, the top 5 mega earthquakes that we have witnessed. You will see that we have not yet recorded any earthquake of magnitude more than 9.5. So earthquake of magnitude 10, as scientists and geologists believe, will be totally catastrophic and devastating in nature. More than 90% of buildings can collapse if such kind of earthquake occurs here. Now, it is not only the magnitude that determines the damage on the economy, on the infrastructure, or on the life of people. Apart from the magnitude, you have the secondary effects that also determines the human casualty. For example, if earthquake occurs and it is associated with the floods, it is associated with the tsunami, the loss of life and to the economy will be much more greater in nature. Similarly, how far is the place from the epicenter? As we discussed in the initial part of the video, the places near the epicenter will be damaged to a greater extent than compared to places far away from the epicenter. Then you have the depth of the earthquake. The current earthquake is a shallow focus earthquake. That is why the energy released is much more lesser. That is much more greater. If suppose a 4.0 magnitude earthquake would happen at 20, 30, 50 kilometer depth, the energy released would be even less. So shallower the depth of the earthquake, greater will be the extent of damage. Then the local geological conditions, how stable are the rocks, and population, architecture of the buildings. For example, Japan experiences more than 600 quakes in the entire year, but the damage is less because their architecture is based on the seismic guidelines, or seismic we can say seismic code or earthquake building code. So all these factors along with the magnitude of earthquake collectively determines the extent of damage that we can see as a result of the earthquake. So fortunately, both the magnitude and other factors in today's case was not so extreme, and that is why damage is very limited in the nature. So that is all about this particular video. I hope you understood the idea behind the genesis of the earthquake and all the associated terms. If you like the video, please hit the like button, share it with your fellow aspirants, as well as subscribe to our channel for more such content. Thank you.